So the historical development of these robots, it's all that started in 1960s. So Unimate was the first industrial robot that was developed by the Unimation. It was used by General Motors for their automotive industry. In their industry, this was the first robot that was used ever as a mechanical manipulator, and the interest grew with Stanford, developing their Stanford robot for assembly tasks. So this is the Stanford robot. This is the Unimation, Unimation's Unimate industrial robot. This is something called as a spherical manipulator or spherical architecture robot. And then MIT also developed a robot with tactile and vision sensors. There was a development of the Puma robot by Unimation again. So it is one of the most celebrated, or you can say one of the most popular robots that has been developed. And then obviously the most important thing was the robots had large size controllers and driver boards. So up to 19, I would say 90s. So your microcontrollers and your processors were actually large sized. So the overall robot itself was, in terms of construction or in terms of space that it would take, was, space was required. But as the technology grew from 1990s to, I would say, 21st century, so your microcontrollers, your microprocessors, they are now smaller and more efficient than the ones that were available here. So robots have become more compact now as any other mechatronic device. All right. Now the scope for robotics. So this is something called as Industry 4.0 technological pillars. So you have so many things that contribute to Industry 4.0, which ranges from cloud computing, mobile technologies, machine-to-machine interaction, 3D printing, advanced robotics, big data analytics, Internet of Things, RFID, cognitive computing, and cybersecurity. So these are the most important pillars that will have a role in shaping the Industry 4.0. For us, if we see advanced robotics, 3D printing is something that keeps us again alive in the Industry 4.0. Now this is something that I was referring to as factories of the future, which is actually envisaged as robots, or we call them as cobots. Cobots means collaborative robotics, where robots interact or robots also collaborate to do a particular task. And there are unmanned trucks that can be used as modular equipment, a computer vision robot with a computer vision. There is IoT sensors for supply chain management. There is industrial augmented reality. There is something called predictive machine analytics. There is blockchain, again a popular technology for ERP and supply chain management. All these things together actually shape up the factories of the future that is envisaged. But actually robots also play a key role in all these things. So designing these robots, designing precise robots, designing accurate robots, designing highly controllable robots, designing flexible robots, designing robots that can interact with humans, or robots which can interact with each other. All these things actually remain, something as I would say a contemporary topic these days. Now this is the overview of the annual installation of industrial robots by regions. Now this is the latest data that I have got from International Federation of Robotics. There's a website on International Federation of Robotics. You can just go through it. This is on internet, and they have published a report on this. So if you see this thing, so in 2018 now, we're seeing particularly in Asia and Australia. So this blue corresponds to that. So you have the annual installation of industrial robots is actually increasing day by day, or you can say year-wise. So there's a growing trend actually into the installation of industrial robots in the industries and at many places. Now the installations as per country, just to give you a stock of the developments or the developed countries, actually China actually is leading in this thing. This is a World Robotics source in 2019, again from International Federation of Robotics. So China is actually leading. China is trying to create the market for the future. Again, in terms of application, the automotive sector actually, where robots are actually being used, but it's the electrical and electronic industry actually where robots are actually taking up the I would say the lead in terms of requirement of robots in those industries also, because you have so much of material, you have so much of handling of electronic and electrical components which has to be done precisely. So robots are really necessary in these industries also. So obviously in industries you have something called as rigid automation, programmable automation, and flexible automation. So rigid automation about where the tasks are specified and the machine is dedicated to task. For example, creating or producing a die or producing some other component where the machine has been dedicated for that. So you can mass produce with this. You can produce thousands of units per day with this type of automation, because you know that this component is required in huge number, and don't worry about the change in the requirement of these components. So rigid automation actually is very useful in that case, where you are focused on a particular item only and you understand the demand. Programmable automation, where you can always change the or you can always program the machine to do various other tasks also. Programmable automation is something like where you want to change actually with the you want to change the this automation components like machines or robots to do a particular task and change for a requirements accordingly. But flexible automation is something where you can change your whole setup based on the demand in the market. So the market says no, we don't want this component, or the market demand for the component decreases, then you go for a change in the whole setup. But it becomes very difficult for an industry to change the complete setup unless the industry has opted for something called as flexible automation. So flexible automation allows you to change, with the demand. So your machines or your systems are developed in such a way that they can adapt to such things. For example, the most important things for such type of automation would be actually robots and other devices which actually have the flexibility, to change, or which can do multiple tasks, or which can do, different tasks. A robot can perform different tasks. So such devices or such machines are actually more useful in this kind of flexible automation systems. Industrial robots in particular, there is a it's a title rather than just robots. Why industrial robots? Industrial robots are actually the largest class of robots that are existing at present. They are mostly fixed robots which do repetitive and often precise mechanical and physical tasks. So these are, the fixed word is important here. They are fixed robots. They are fixed at some place. So there could be mobile robots also that we will see in the classifications and their applications accordingly. So these robots provide many of the modern industrial areas of the modern industrial automation, as we have seen previously, and are mainly concerned with the task performed in structured environment. So this robots though can perform in unstructured environments also, but industrial robots that we see, the robots that exist today, the largest class that has been said, the largest class actually are performing things in a structured environment. It's a dedicated environment, or which is a it's a known environment which has been structured properly for a particular task. So robots operate mostly in the structured environment, or you can say the largest class of robots, which is industrial robots, they perform mostly in the structured environment. Now these robots are mostly perceived by everyone, though we may we may also have this perception about robots that they are more of anthropomorphic. It refers to human like, or you can say human like means is a humanoid kind of a robot which looks like a human, replicates a human kind of a shape. But so anthropomorphic would mean human like. So robots are expected to be human like, because as we have seen from the first slide, where humans would like to imitate their behavior by another machine. So you would like to have something similar to that, but the actual robots are less anthropomorphic, but they're more a mechanical manipulator in that sense, which is an articulated body, which means a body connected by joints, or a system connected by joints. So there are links, link number 2, link number 3 in a robot. They're connected by joints J1, J2 and other things. So this is connected to, let's say, ground. So there is a robot, three degree of freedom robot, which is actually connected together by the links are connected together by joints. So this may be similar to a human arm, which is again having some, you know, joints like one joint, joint number two, joint number three, links here, and other links in terms of fingers here. So kind of imitating that behavior. They are some of like human, arm shaped or something like that, but they may not be necessarily humanoid. Humanoid would mean very, similar to the whole human body, where you have limbs, where you have arms and legs, and maybe a head which consists of sensors and other things. It's not necessary to have a robot like this. Robots are generally or mostly in this way, which is more of a mechanical manipulator, or we can say an articulated body. Articulated body means bodies connected with joints. All right. Now coming to the applications of robots, or you can say robotics in general. So the most important sector that robotics actually caters, or the first sector that robotics actually took, the shape into, was automotive sector. The development of automobiles, where the General Motors has been the front runner in this case to use the Unimation robot. But obviously in aerospace also, where mostly the jobs that are done by robots are welding, painting, and in assembly tasks also, where obviously we have industrial robots. Now we have material handling, also one of the important aspects in any industry, where we have automated guided vehicles. They are also classified sometimes as robots. And you have intelligent machining centers, which is like a CNC or other things. They are also sometimes, roughly classified as robots. You have flight simulators, where you have hexapods that help you to simulate a flight, or you can call them as vehicle or flight simulators. Hexapods is again a variant of robot. We'll come to that later on. Robotics has a profound application in medical arena, which is robotic surgery, which is very contemporary these days. Haptics, this is related to the sense of touch, and teleoperation, where you operate a robot from a different place. Now we'll come to these things again in the next slide. You have space. Maybe we'll not discuss these things like Mars rover that is used in space exploration. You have flexible robots that are used in space stations. Flexible obviously would mean we want not actually flexible in terms of their application, but flexible in terms of the links. It is referred here, which makes them lighter, which is sometimes very necessary when you talk about space and other things. You have underwater robotics, or underwater robots, which are used for inspection and cleaning of underwater pipelines, which are difficult to be done by humans sometimes. Again, replicating that behavior. You have in defense, you have surveillance, you have disaster management, where you use mobile robots. You use in security something called as autonomous robots or quadcopters. You must have heard of these popular names. In energy, you have nuclear reactors, where radioactive material handling is hazardous, and the deployment of it is again hazardous. So robots can operate in obviously hazardous environment. Then obviously in electronics and food industry, pick and place component assembling, cobots are used there mostly. It's a very contemporary thing called cobots, collaborative robotics. And again in agriculture, you have monitoring and inspection that can be done by robots, which is being used currently for large fields and other things. And then obviously in physical rehabilitation, human care, or you can say human robot interaction, where you have humanoid robots that are being popularly actually developed. And then in construction and minings, where you have autonomous trucks and other. So apart from all these applications that I have listed, you have so many other applications of robots in general.